Hi there, so today we're looking at Unit 5.8 using the nth term of a sequence. Our objectives today, to use the nth term to generate terms of a sequence and to find the nth term of an arithmetic sequence. So prior knowledge before we start then, you need to have an understanding and be able to generate term-to-term rules. You need to be able to substitute into a formula or equation. You need to be able to use BIDMAS, remembering that means brackets, indices, divide, multiply, add and subtract. And you should be able to solve equations using the balancing method. If you're not happy with any of those, please stop this video and go back and have a look at some of the previous lessons first. Things you'll need to complete this lesson: you need your maths book or some paper to write on. You'll need a pen or a pencil, and you may wish to have a calculator for the more tricky questions. Okay, so looking at sequences from nth term rules then. So here we've got a sequence 3, 6, 9, 12, 15, 18, and the rule for this sequence is 3n. So each term can be found by multiplying the position of the term by 3. So these are our positions. So 3n means I'm going to do 3 times the number 1, the first position. 1 times 3 is 3. Or 3 times the second position. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So n stands for our position number. So that's why it's often called an nth term rule. Okay, so either position to term rule or nth term rule is quite often, because we're using this letter n to stand for the number of the position. Remember, the positions are simply the order 1, 2, 3, 4, 5, 6 as we move along. Now, the reason we want to find these is because a term-to-term rule can help us to get from one number to the next number, which is great if I only need a small amount of numbers. But if I wanted, for example, the 100th term in this sequence, I don't want to have to write out 100 numbers to be able to find it. I want to be able to find it quicker. So by creating an nth term rule, we can simply swap the letter n for the position we want, which is number 100 in the list. 3 times 100 is 300. So the 100th number in this sequence is 300. So you can see this has a lot more uses than our term-to-term rule. It means it saves us lots of time if we want to find a number further down the list than we want to write it out. So how can we use them? So let's start off by using them the rule to find the sequence. So our first rule here is 4n plus 1, remembering n is simply the position number. So if I want to find the first 5 terms, I've got to substitute n for 1, then 2, then 3, then 4, and then 5, the number in the list I'd like to find. So our first one, our 4 times our position number 1, we'd like the first number in the list, plus 1, following our rule, using BIDMAS, comes to 5. Then we simply swap the n for the next position, which is number 2 in the list. 4 times 2 plus 1 is 9. And we continue that for those first 5 terms. So we were asked to find the first 5, so that's numbers 1, 2, 3, 4, and 5. These are the first 5 numbers in our sequence. So our sequence would start 5, 9, 13, 17, and 21. All right, let's try another one then. So this time we've got 14 minus 2n. So again, remember it's the n, the position number that we're swapping, and we've been asked to find the first 5. So again, we're going to swap n for 1, then 2, then 3, etc. So this time I've got 14 minus 2 times 1. Remember, 2n means 2 times a number, and we want number 1 in the list. Following BIDMAS, I need to do my 2 times 1 first. 2 times 1 is 2, and then do 14 minus 2, which is 12. We now substitute in our second position, so number 2 for the second position. Again, follow BIDMAS. 2 times 2 is 4. 14 minus 4 is 10. And we continue for our third position, our fourth position, and our fifth position. So that's our first 5 terms, and we can then write them as a list. And we have got 12, 10, 8, 6, and 4 are the first 5 numbers in that sequence. So to recap, when given a rule, if we're asked to create the sequence, we simply substitute the letter n, the position, for each value that we'd like to find. Often we're asked to find the first few, so we start with 1 and then carry on from there. Okay, so here are some for you to have a go at then. You need to find the first 5 terms in each of these sequences. So remember, you're swapping the letter n for 1, then 2, then 3, then 4, then 5. Make sure you follow BIDMAS as you work these out. If you need to, you can also use your calculator. Pause the video, have a go now. Okay, let's have a look at the solutions then. So for our first one, we've simply got 5n. So that's 5 times our position number. We're starting off with the position number 1. So 5 times 1 is 5. Then position number 2 and 3, etc. So we do that 5 times for our first 5 positions. And our sequence reads 5, 10, 15, 20, 25. Our second one then, we've got 7 times the position number minus 4. So 7 times 1 minus 4, first of all, again, make sure we use BIDMAS. We get 3, then 10, 17, 24, 31. So again, it's good to write them out as a sequence at the end. For this one then, 5 times our position plus 1. So again, swapping that n for 1 gives us 6. Then for 2, we get 11. And continue from there for the first 5. We get 6, 11, 16, 21 and 26. Our last one then, we've got 21 minus 2 times our position. So again, make sure with these ones we definitely use BIDMAS. We get 19, 17, 15, 13 and 11. Okay, if you need to pause the video now to just check through your answers thoroughly, please do that. Make sure you're happy with them before you move on. So we've used the rule then to find the different values in our sequence. But how do we work out that rule? So this time we've been given the first 6 numbers in a sequence and we need to work out the position to term rule, the nth term rule. Now the way to do that, there are some steps we can follow. The first one is to find the difference between each term. So essentially find the term to term rule. Okay, so to get from 5 to 7, I've added 2. From 7 to 9, we've added 2. From 9 to 11, we've added 2. Make sure that rule works for all of the numbers that you've got. So our rule here is plus 2. Now I haven't written the plus in front because it's a positive number, so we normally just write those on their own. So that's my 2. The next step is that we're going to multiply that by n. So that's our position number, remember. N is the position. So this is 1, 2, 3, 4, 5, 6. So I could swap n for 1, 2, 3, 4, 5 or 6. So the difference between them, the term to term rule, multiplied by n, which is going to be our position number. Now the next step is to check our values. So we've got 2 and our first value here is 5. So they're not the same. If they were the same, we'd be done. If they're not the same, I need to work out, well, how do I get from 2 to 5? And I would need to add 3. 2 plus 3 would give me 5. So we simply write that plus 3 at the end of our rule. So our rule is now 2n plus 3. So to recap, find the difference between the values and write it down. Put an n after it. Check whether your number matches the first number in the sequence. If it does, do nothing. If it doesn't, what have you had to add or subtract to it to get to this number? And we write that at the end of the sequence. So the rule for this sequence was 2n plus 3. If you need to, please pause the video and write down those steps. Okay, let's do a few more examples to make sure that we're happy with this. It's quite quick once you get going with it. So first step, find the difference between the numbers. So from 6 to 10, we've added 4, we've added 4, we've added 4. Always check it a few times to make sure that is the case. Don't just do the first one and hope that it's the same for all of them. So we write down the 4. We put an n after it. Now we have the number 4. We'd like our first number to be 6. So to get from 4 to the number 6, we would need to add 2. and we put that at the end, and we're done. Let's try the next one. From 5 to 3, we're descending, so we take away 2. From 3 to 1 is take away 2. 1 to -1 is take away 2. Again, always check a few of them. So we write down this time -2. Put an n after it. Now we've got -2 and we'd like 5. So I've got to count from -2 up to 5. And to get from -2 to 5, that's getting warmer, so I need to add 7. So I like to think of my negative numbers as temperature, so minus being cold, positive being warmer, so I want to go from cold to warmer, so that's plus. For the next one then, so from 4 to 7, I add 3, from 7 to 10 we add 3, from 10 to 13 we add 3, so we can see that we continually add 3, so we write down our 3. We put an n after it. To get from 3 to our first number, which is 4, I would need to add 1. Now there's another part to this question. What's the 20th term in this sequence? Well, remember n stands for the position number. So if I want to know the 20th number in the sequence, I swap n for 20. So that's 3 times n plus 1. So we would do 3 times 20 plus 1, which is 61. So we're simply substituting in the position we want in place of n, much like you did in the previous tasks. The last one then, a descending sequence, so to get from 11 to 5, I would have to subtract 6. To get to -1, I'd have to subtract 6, so it looks like we're subtracting 6 each time, so we write down the -6, put an n after. Now again, let's go back. I'm at -6, which is pretty cold, and I need to get to 11, which is nice and warm. So to count up from -6 to 11, I would need to add 17. This time we're asked for the 50th term in the sequence. So remember, we can only swap the letter n for the number 50, and that means -6 times. So -6 times 50 plus 17, following BIDMAS. -6 times 50 is -300. Add 17, so if I'm at -300, that's really, really, really cold, and I want to add 17, so that's going back up towards 0, I end up at -283. So be careful with your negative numbers if you're not confident with those, and you can check your work with your calculator if you need to. Make sure you're happy with those examples before you move on to have a go for yourselves. Okay, so your turn then. So for each sequence, you need to find the nth term rule and then find whichever term you're asked for. Pause the video, have a go now. Let's look at the solutions then. So for the first one, the rule is 4n plus 4. If we substitute in 50, we get 4 times 50 plus 4, which is 204. The next one, the rule is -2n plus 21. We're going to substitute in 100, so -2 times 100 is -200, plus 21 is -179. For the next one, we've got 3n minus 1 this time. Substitute in 25. 3 times 25 minus 1 is 74. Our next one then, 6n plus 294. We're going to substitute in 10 for n. So 6 times 10 plus 294 is 354. And finally, 5n plus 5. Substitute in 20. We get 5 times 20 plus 5 equals 105. Make sure you've marked those, and if there are any that you haven't quite got right, go back, have another look, and maybe check that you've used BIDMAS correctly. Okay, so sometimes we're asked to prove whether numbers are in a sequence as well. So let's have a look at this exam question. It says here are the first 5 terms in an arithmetic sequence. 5, 9, 13, 17, 21. Part A, then write down an expression in terms of n for the nth term of this sequence. So when it says that in terms of n, it simply means we need to have the letter n in our answer. So we're going to write down our rule. So first step, find the difference. So from 5 to 9, that's plus 4. From 9 to 13 is plus 4. 13 to 17 is plus 4, 17 to 21 is plus 4, so it is going up the same every time. So I can write down my 4. Put an n afterwards. I have 4. I'd like my first number to be 5, so I'd need to add 1. So that's now our nth term rule. Okay, so sometimes this wording can be a little bit confusing. All it means though is that we've got the letter n in our answer, which we have. Now it says, is 39 a term in the sequence? You must give a reason for your answer. So to check if 39 is in the sequence, we're going to make our sequence equal to 39. So our 4n plus 1, we want to see, does it equal 39? So we're going to use our knowledge of algebra to solve that. So remember, to get rid of plus 1, we need to subtract 1 from both sides. If I subtract 1 from both sides, 4n would equal 38. To find n, I now have to divide by 4. So if I divide both sides by 4, n would equal 9.5. Now remember, this is number 1, 2, 3, 4, 5. So the position numbers are always whole numbers. So 9.5, position number 9.5 can't be a position in our sequence because they need to be whole numbers. So that 9.5 is telling me that 39 is not a term in the sequence. It's between the 9th and 10th terms. So whatever number we have here, you need to say whether it is or isn't in the sequence, and you need to give your reason. So our reason is 9.5 is between the 9th and 10th. All our terms are whole numbers. So whenever you get a decimal, you need to say which two terms it's between. Let's look at another one. So we've got another sequence this time, 7, 12, 17, 23, 28. Is 202 a term in the sequence? Well, to be able to find that out, first I'd have to find the nth term rule. So our nth term rule, we're adding 5, we're adding 5, we're adding 5. So we've got our 5, then our n. From 5 to 7 we add 2. So there's our nth term rule, and we want to check if 202 is in the sequence, so we'll make it equal 202. Now we'll solve that equation for n. So we're going to subtract 2 from both sides. 5n is equal to 200. Then to get n on its own, we need to divide by 5. So n equals 40. Now 40 is a whole number. So again, our reason, yes, it's the 40th term in the sequence. So if n becomes a whole number, then that's the term that our value is. So 202 is the 40th. So if I kept writing this sequence out until I got to the 40th number, that would be 202. Make sure you're happy with that. Read it through again if you need to. Okay, so 2 questions there then for you in reasoning, so to check whether terms are in a sequence or are not. So if they haven't given you the nth term rule, you'll need to work that out first and then make it equal to your value and solve the equation. Pause the video, have a go now. Okay, so for the first one then, we're told to show that 220 is in the sequence. So it must be in the sequence, so all we've got to prove is, well, where in the sequence is it? So if we first find our nth term rule. So from 3 to 10, we're adding 7. Each time we're adding 7, so that's 7n. We have a 7 and we'd like a 3, so we'd have to subtract 4. So our nth term rule is 7n minus 4. And we're going to make that equal to 220. To solve it, we need to add 4 first of all to both sides. We get 7n equals 224. Then, to get rid of a times by 7, we're going to divide both sides by 7. N is 32. So 220 is the 32nd term in the sequence. So nice whole number. And it tells us, when it says show that it is, then we know that we should be expecting a whole number here, but it's good to write it out as a sentence at the end. Okay, so this time we've been given the nth term, 3n plus 5, and we're asked, is 108 in the sequence? So we'll make our nth term equal to 108. First step then, get rid of plus 5 by subtracting 5 from both sides. So 3n equals 103. divide both sides by 3, and we get 34.3 recurring. So not a whole number. So our first bit here is 34, and then we've got some bigger than 34. So n must be between the 34th and 35th term. So 108 is not a term in the sequence, and we have stated which two terms it's between. Okay, so that's really good practice to say which two terms your number is in between. All right then, last thing we're going to look at today then is using patterns for our sequences. So as well as having just a number sequence, we could have a pattern sequence, and we can develop a number sequence from there. So we're asked first of all then to draw pattern 4. So we need to look at the pattern and see how it's developing. So we started with 3 circles. We've got our 3 circles, but we've gained 1 under the left and 1 under the right. Our next one, we've got that pattern 2 repeated with an extra 1 on the left, an extra 1 on the right. So our next pattern we can imagine would be the same, but with another one on the left and another one on the right. So when we've got a diagram pattern, we need to see what extra has been added or taken away for each different development of that pattern. Part B, we're asked to write down an expression for the nth pattern. So it wants an nth term rule. So we need to turn our pattern from a picture into numbers first. So in our first one, we had 3 circles, then we had 5, then 7, then 9. So we can now develop our nth term rule. So we're adding 2, adding 2, adding 2, so that's 2n. And we would like the number 3, so 2n plus 1. So remember the difference between them, then our n, then check our number 2 to 3, we add 1. So that's our nth term pattern. Part C then, how many circles in the 50th pattern? We substitute n for 50. So 2 times 50 plus 1, there will be 101 circles in the 50th term. Okay, so the 50th pattern along. So we can see why this is really useful. We wouldn't want to draw this pattern out 50 times to find out how many circles there are. Okay, so your turn again then. So pause the video, have a go at drawing the next pattern, writing down the number sequence, finding the nth term, and then how many dots for pattern 30. Pause the video, have a go now. Okay, so the next pattern in the sequence should look like that one then. We've added dots to each end of the line. So we've added an extra one to each end and one to the bottom there as well. So write down the number of dots needed for the first 6 terms. So we've drawn the first 4. The first one had 4, then 7, then 10, then 13. And if we wanted the next 2, if we see how the pattern progresses, we're adding 3 each time. So we get 16 and 19 for the first 6 values. Now we're asked to write the nth term. So we know it's going up in 3, so that's 3n. To get from 3 to 4, we add 1, 3n plus 1. And how many for the 30th? So substitute n for 30. 3 times 30 plus 1 means we would need 91 dots for the 30th pattern. Make sure you're happy with using those patterns to turn them into numbers and find your nth term. Okay, thank you for working through that lesson with me today then. So that's the last lesson in this particular unit. Look forward to seeing you next time.